Good morning, guys. It should be Tuesday when you are watching these notes. If it's not, make sure you are going to the right video for the day. All right. Today we're going to be talking about the two different types of waves, okay, that we're going to actually be looking at. I've got transverse waves and I've got longitudinal waves, okay. We're going to look at the difference between these two today. And remember, this is just the start of this. So if you're not completely comfortable with it by the end of this video, that's okay. When I get back, we are really going to jump into it, and eventually you'll be super comfortable with the difference between these two guys. Okay, so the first one is a transverse wave. A transverse wave looks like this. Okay, we can, one example is light, and this guy has to travel through a vacuum. And remember, that is not a vacuum cleaner in the house. That is empty space. Okay, so just make a note when you're making these notes. A vacuum is just empty space. Okay, unlike longitudinal, for example, sound, which travels through a medium. And a medium is simply a solid, liquid, or a gas. Okay, so let's look at transverse wave, and we are going to start by looking at the different parts of this guy. Okay, so the first thing you do when you draw this wave is you make the line, all right, and you draw a line right down the middle of it. Now, this guy is called your rest. Okay, it's kind of that place of equilibrium where the wave is at rest. Okay, and so now we are going to look at the other parts of this guy. Right. So in a transverse wave, you've got a crest, amplitude, trough, and a wavelength. Okay. And when I'm in class, we are going to look at frequency. Okay. So how often this wave is occurring. Now, let me move this. So our crest, think about something cresting. I always think about, something rising to the top. And so our crest in this example are the very, very tops of this wave. So you've got your crest, and crest. Okay, pretty simple. And then your trough, I think of something that a pig eats out of. Okay, and they're close to the ground, and kind of like right here, the trough is at the bottom of the wave. All right, so far so good. So let's go to wavelength. When you measure wavelength, you can do it in two ways. Give me just a second. All right, when you measure it, you can do it in two different ways. You can go from crest to crest or from trough to trough, okay? So if I wanted to measure the length of a wavelength here, I would go from this crest to this crest, or I could go from this crest to this crest, okay? So that would represent, this one's one wavelength, from here to here is two wavelengths, okay? Next, you could go from trough to trough, okay? And that would represent one wavelength, okay? So however you want to do it, but crest to crest or trough to trough, okay? So far, so good? All right, next we're going to do amplitude. Amplitude's pretty simple. If you look at crest, look at the word crest, look at the word rest. The only thing that is missing out of rest is the letter C, okay? So I relate those two, and amplitude is simply rest to crest. Rest to crest. Rest to crest, okay? And this represents my amplitude. Amplitude. Okay, so eventually you're going to have to know how to label one of these guys. It's not very hard. You just have to do it and get practice at it, okay? So when you're practicing, you need to make sure you've got crest, amplitude, trough, and by that you can determine your wavelengths, all right? So that is your transverse wave. And remember, transverse vacuum. All right, next we're going to do longitudinal. In longitudinal, an example here is sound, okay? And sound waves have to travel through a medium, which is simply a solid, liquid, or a gas, okay? Now, there's three things that we can measure here. We can measure, you have these things called compressions, rarefactions, and I know that's probably a new word. Think about compression when I put a compression sock on, or let's say I hurt my ankle and I have to put a compression sleeve or something on it, or a shooting sleeve that compresses when I'm playing basketball. It just pushes it together, tightens it together, okay? And it's very, very similar here. That's going to be the spot in this wave where energy is close together, all right? And the next thing we can measure is the wavelength. Cool? Now this one's going to look different. It's not going to look like your typical wave that you would see at a beach, but it's going to look like this. You're going to have these particles that are really, really close together. Then I'm going to use another color just so you can tell the difference here. And then you're going to have ones that are further apart. Okay, so which one here do you think represents compression? Definitely this one, because those particles are really close together. Okay, so I'm going to do the same thing. The compression part of our wave. And then here we're going to have another, this is what you call rarefaction. We'll get used to saying that word, rarefaction. All right? So when we label them, we start off with compression. And remember, the close parts together are your compressions. So this is compression. Where's my other one? Right here. Okay? And then my rarefactions are the ones that are further apart. Okay, so the wavelength here is going to be measured a little bit different, but it's not hard at all. Okay, so probably common sense the way you measure them. We are going to go from either compression to compression. That's one wavelength. Or you can go from rarefaction to rarefaction. That's another wavelength. Okay, so very, very plain and simple. They stay together. You either go from one to one or one to the other one. Okay, so compression, compression, or rarefaction to rarefaction, which is how you label them. The biggest, most important part here is we know how to label this guy, how to label our transverse wave, okay? And that transverse wave, an example is light. Light has to travel through a vacuum, which is simply empty space. Or you've got longitudinal wave. An example is sound, and it has to travel through a medium. Okay, so these notes should be going in your interactive notebook. And when I get back on Thursday, we will be looking at this in more detail. Okay.